So as I was saying, the sine phi theta is imaginary. It's in terms of it is a multiple of imaginary. You can say it's a coefficient of an imaginary number. Therefore, the only other things that are related to it, although it could legitimately be equal, are the other values that are imaginary. That means to say that what I'm going to do is I'm going to take the I sine phi theta here, which is what we want on the left. Again, we're looking to keep the sine phi theta because we know that that's what the problem is looking for us to produce. Sine phi, or to consider, sine phi theta is only going to be equal to the equivalent imaginary values on the left-hand side. So we have our I on this left. What do we have that's I on the right? And that is, if you can see, we have the 5 c to the power 4 s, so that's cos to the power 4 sine theta. We have the minus 10 cos squared sine cubed, and we have the I s to the power 5 here. Now, in these circumstances, I can factorize out each I, and I'm left with the idea then that the sine phi theta must be equal to these three terms. This is probably not the best way to state it. What would be stated is in terms of imaginary numbers or in terms of values on the imaginary axes. Therefore, we have sine phi theta, or therefore this becomes sine phi theta equals the following three terms. Now, what else needs to be considered is that there's only one sine theta in here. So what I'm going to do is I'm going to look at our problem in terms of a puzzle. There is one sine theta, but here there is three. So I'm going to see if I can convert two of those into a cos theta. And here is 5, so I'm going to consider if I can convert 4 of those into cos thetas. And how do I do that? Well, for example, I will simply just use the idea that cos squared plus sine squared equals 1. And as a result, sine phi theta is equal to 5 cos 4s. I'm keeping that. There's one sine theta in here, but I'm going to get rid of 2 of the sines and put in 1 minus cos squared theta. And I'm going to get rid of 4 of the sine thetas and put in 1 minus cos squared theta squared. This then allows me to factorize out sine from all 3 of them, leaving me with this. And as a result, I am then left with this situation here where these are all in terms of cos. With a little simplification, we can have 16 cos to the power 4 minus 12 cos squared plus 1. And further, we can then expand it back out. Instead of using s and c for our own advantages, we can expand it back out to this, which is exactly how it is necessary to prove the following problem. Thank you.